A ball is shot up vertically from the surface of another planet. Oh boy. So there's a lot of ways we could do this problem. We want to basically come up with the equation of motion for this thing. So let's just kind of be clear. Eventually, you want our equation to look like this. Y is 1 half at squared plus v naught t plus y naught. Okay, and again, we want values for a, v naught, and y naught. That's really what's going on here. There's a number of ways we can do this. So one approach I saw, I'm going to call this the Sarah Hong approach, because that's who came up with it, and that's who I stole it from. So what Sarah Hong said was, I don't even want to worry about any of this. Let's do this in a simple way. Why don't we start up here? We'll say that V naught is 0. Oh, so you eliminate a letter you have to worry about that you can go back and get later on. And then the other thing is, we can set this equal to 0 and see how far it falls. And I was just like, wow, that's just a great idea. Well, we got the numbering here as 30, so we get the 150 taken care of, 60, 90, 120, 150. So here's what Sarah said. Why don't we go and just try to solve it that way? So she said 150 equals 1 half times a. And then the thing is, the time from here to here, since we set this as our initial position and setup, we take 2.5 seconds to travel. And then when we actually solve for a, we got 48 meters per second squared for the acceleration, which I thought was an awesome way of doing it. So that is the Sarah Hong approach. And then there is also the Cameron Newman approach, where Cameron said, I don't like any physics equation at all. I'm putting words in her mouth. I don't even know if she ever said that in her life. Cameron, I apologize if I'm speaking for you. It's probably a new low in the depths of mansplaining. So 1 half at squared plus. So we don't want to work with that. What Cam suggested was, well, why don't we use the general equation of a parabola, where I'm trying to come up with the equation. So y is a t minus. You know what? I'm going to write these with capital letters. So y is a t minus b squared plus c. And we got to solve for a, b, and c. So this is what Cam noted. What Cam noted was that at, say, 5 seconds, I'm, or at, at 2.5 seconds, I'm at 150. So we can actually, figure out two of the letters right away. So one thing we could do, or another thing is, we can say the following. At 2.5 seconds, I'm at 150. So I'm at 150 equals a times t minus 2.5. And then here's the thing. I don't want to mess with any times here, so what I'm going to do is this. I'm guessing that b is 2.5 and that c is 150, because that gives me the right answer, because if I put 2.5 here for b, then when this is 2.5, what I get is everything works out nice and perfect. So let me say it one more time in a better way. Try b is 2.5 and c is 150. Why? Because it gives us like a convenient answer. We can actually say then that if we do that, if we let b equal 2.5, then when c is 150, y is 150, and we're good. Okay, so what that leaves us then is we have an equation that looks like this. We have a t minus 2.5 squared plus 150, and then we got to figure out what a is. So to do that, what I'll do is this. I will say that at time equals 0, we know that y equals 0, and we'll try to solve for a that way. So we'll say 0 equals a times 0 minus 2.5 squared plus 150. And we actually solve for that. We're going to end up getting that a is negative 24. So this is what we end up getting. We end up getting y is negative 24, t minus 2.5 squared plus 150. When you multiply all that out and simplify, you're going to end up getting an equation that looks like this. You're going to get y equals negative 24 t squared plus 120t plus 0. That's it. So that's Cam's approach, and that's one really good way of doing it. Let me go back to Sarah's approach here. So what Sarah obtained was that the free fall acceleration was 48 meters per second squared. And then to get the initial velocity, we'll say v equals at plus v naught. And here's what we'll note. So 0 is 48 times 2.5 seconds plus the v naught that we launch at, sorry, negative 48. Because we actually end up slowing down here. It's a negative acceleration. And so we end up getting that v naught is 120 meters per second. So let's go back and take a look at Cam's approach. So this part here, the negative 24, is actually 1/2 a. So when we say that 1/2 a is negative 24, we're getting that a is negative 48 meters per second squared. Similarly, we know that this is v naught from our equation, so we have v naught as 120 meters per second. So both approaches give us the same answer. So that's number 1 on the free response.